Take a deep breath and let your shoulders drop, allowing the weight of the day to melt into the surface beneath you. As your eyes close, imagine the darkness behind your lids transforming into the vast, silent reaches of the Serpens constellation, where the Eagle Nebula awaits our arrival. We are traveling 7,000 light-years away from the familiar comforts of Earth, moving toward a celestial cathedral known to astronomers as Messier 16, or simply M16. To understand this distance, consider that light travels at approximately 186,000 miles per second. The light entering your mind's eye tonight has been journeying through the vacuum of space for 7 millennia, leaving the nebula at a time when humanity was only just beginning to develop agriculture and permanent settlements. As we approach this cosmic nursery, the scale of the universe begins to stretch your perception. The Eagle Nebula is not merely a cloud, but a gargantuan structure spanning roughly 70 by 55 light-years across. One single light-year is approximately 6 trillion miles, a distance so vast that it defies the human capacity for measurement. Yet here, it is merely a yardstick for the beauty of the void. You find yourself floating now, weightless and unburdened, at the edge of the pillars of creation, the most iconic feature of this nebula. These 3 towering columns of gas and dust rise up like the fingers of a giant, or the trunks of ancient celestial trees. The tallest of these pillars is a staggering 4 to 5 light-years in height. To put this in perspective, if you were to place our entire solar system at the base of this pillar, the outer reaches of our planetary neighborhood would not even register as a speck of dust against its towering majesty. Here, the comforting void is not empty, but filled with a fine, microscopic mist of interstellar dust. Feel the imagined texture of this dust against your skin. It is composed of silicates and carbon, much like the graphite in a pencil or the sand on a beach, but refined into particles smaller than the soot from a candle. The temperature here is a study in extremes. Inside the dense clouds of the pillars, it is profoundly cold, hovering between 10 and 20 Kelvin. This is roughly 440 degrees below 0 Fahrenheit, a temperature so low that molecular motion nearly ceases. This stillness is not frozen in the way ice is on Earth. It is a quiet, rhythmic stasis. Yet, contrast this with the surrounding environment. See where the nebula is classified as an H2 region. This means the hydrogen gas has been ionized, stripped of its electrons, by the blistering ultraviolet radiation pouring off the nearby stars of the NGC 6611 cluster. This radiation heats the exterior surfaces of the clouds to thousands of degrees, creating a slow, invisible evaporation, known as photoevaporation. Imagine this process as a gentle cosmic wind, eroding the edges of the pillars over millions of years, sculpting them into the magnificent shapes we observe today. As you drift closer to the heart of the nebula, you encounter the open star cluster NGC 6611. Discovered in 1745 by the Swiss astronomer Jean-Philippe de Chezeaux, this cluster is a concentrated family of roughly 8,100 stars. These are young stars, many of them massive, brilliant O-type and B-type stars that glow with a fierce blue-white intensity. Their light is what illuminates the surrounding nebula, turning the dark gas into a glowing tapestry of reds, oranges, and deep indigos. The red hues you see are the signature of H-alpha emissions, light released when an electron in a hydrogen atom drops from its third to its second lowest energy level. It is a soft, pulsing crimson that fills the vacuum, a visual heartbeat of the universe's most abundant element. Within the pillars themselves, something miraculous is happening in the dark. These are the EGGs, or Evaporating Gaseous Globules. These are dense knots of gas that are slightly more resistant to the ultraviolet radiation than the surrounding mist. Because they are shielded, the gas inside can collapse under its own gravity. Here, the slow dance of physics takes over. Over hundreds of thousands of years, gravity pulls the hydrogen closer and closer together, increasing the pressure and the heat at the center of these cocoons. You are witnessing the birth of protostars. It takes approximately 250,000 years for a star to emerge from its dusty cradle, a blink of an eye in cosmic time, but a span of 100 human civilizations. Feel the slow, deliberate pressure of gravity as it draws the universe together, a rhythmic, tightening embrace that turns chaos into light. Consider the composition of the nebula's atmosphere. It is a vacuum more perfect than any we can create on Earth, yet it contains the seeds of everything that will ever exist. The silicates and carbon grains are the same materials that will one day form the rocky crust of new planets, the iron in the blood of future beings, and the calcium in their bones. As you float in this nursery, you are looking at your own ancestry. The Eagle Nebula is a factory of life, a place where the debris of old dead stars is recycled into the fire of new ones. This cycle has been repeating for nearly 13.8 billion years, a steady, unhurried pulse that ensures the continuity of the cosmos. In 1995, the Hubble Space Telescope captured the most famous image of this region. But in 2022, the James Webb Space Telescope looked through the dust using infrared light. This transition from visible to infrared light is like closing your eyes and feeling the warmth of a fire you cannot see. Infrared light has longer wavelengths, allowing it to pass through the thick dust clouds that block our vision. In the infrared, the pillars become translucent, revealing thousands of sparkling stars hidden inside. These stars are embedded, tucked away in their nurseries, like infants in a blanket. Imagine the silence of this interior space, a silence so deep it feels like a physical weight pressing gently against you, inviting you to let go of your thoughts. The pillars are not static. They are moving, flowing at velocities of several kilometers per second. To our eyes, they appear frozen in time, yet they are a dynamic fluid, shaped by magnetic fields that thread through the gas like invisible wires. These magnetic fields help guide the collapse of gas into stars, preventing the pillars from simply dissipating into the void. There is a profound sense of order here, a set of laws, thermodynamics, electromagnetism, and gravity that govern every swirl of dust and every flicker of light. It is a clockwork universe, operating on a scale that makes our daily worries seem like the briefest of whispers in a hurricane. The Eagle Nebula is located in the Sagittarius arm of the Milky Way galaxy. As you drift, look back toward where our sun would be, a tiny yellow spark 7,000 light-years away. From this distance, the history of Earth hasn't happened yet. The light from our sun that is currently reaching the Eagle Nebula left Earth during the Neolithic period. The universe is a time machine, and as you nestle into the softness of your bed, you are synchronized with this ancient traveling light. As we focus on the sensory experience of this nebula, imagine the smell of space. Astronauts who have conducted spacewalks often describe the scent of the void as a metallic aroma, like seared steak or hot welding fumes. When this comes from polycyclic aromatic hydrocarbons, molecules that are abundant in nurseries like the Eagle Nebula. Imagine a faint, charred, sweet scent drifting through the cold. a signature of the chemistry that builds worlds. The air you breathe now is thick and rich compared to the ethereal thinness of M16, but the atoms in your lungs were once forged in a place exactly like this. The color palette of the nebula is a symphony of chemistry. In addition to the red of hydrogen, there are the emerald greens and sapphire blues of doubly ionized oxygen, known as oxygen 3. These colors are not painted on. They are the result of atoms being energized by the light of the NGC 6611 cluster, which sits about 20 light-years away from the pillars. The light travels from the cluster, hits the gas, and causes it to glow, much like a neon sign in the window of a quiet shop at midnight. The glow is steady, unwavering, and soft. As you continue to float, notice the Bok globules scattered throughout the nebula. These are small, dark, isolated clouds of very cold gas and dust. They are named after astronomer Bart Bok, who hypothesized in the 1940s that they were the precursors to stars. They look like dark raindrops suspended in a sea of light. They are the quietest places in the nebula, spots where the density is high enough to block out even the light of the nearby stars. Imagine retreating into one of these globules, a private, dark sanctuary where the temperature is a constant soothing cold, and the rest of the universe is just a faint, distant glow. The Eagle Nebula teaches us about the patience of the universe. A single star cluster like NG C6611 can contain 8,100 stars, yet it occupies only a small fraction of the nebula's total volume. The space between things is what defines the beauty of the objects themselves. The comforting void is the canvas, and the pillars are the brushstrokes. In this nursery, time is measured not in hours or days, but in the half-lives of elements and the orbital periods of binary stars. The pillars themselves are estimated to be only about 100,000 years old in their current form. They are transient, a temporary masterpiece of gas and shadow that will eventually be blown away by the very stars they are creating. In another million years, the pillars will be gone, replaced by a cluster of brilliant new stars that will drift apart and find their own places in the galaxy. When this knowledge, that even the most monumental structures in the heavens are part of a shifting, changing flow, is a reminder to let go of the need for permanence. Everything is in transition. Everything is moving toward a new state of being. Feel the weightlessness of your limbs as they settle further into the mattress. The gravity that shaped the Eagle Nebula is the same force that keeps you tethered safely to the Earth. It is a universal constant, a gentle pull that connects the smallest atom to the largest galaxy. As you drift deeper into this mental journey, the 8,100 stars of NGC 6611 seem to pulse in time with your breathing. The 70 light-year span of the nebula becomes a blanket, wrapping you in the history of the stars. You are safe here, in the cold, bright, silent cradle of the Eagle Nebula, where the only thing that matters is the slow, rhythmic dance of light and dust. Each breath you take is a connection to the H2 regions and the silicate grains, a quiet affirmation that you are a part of this grand, scientific masterpiece. The nursery is quiet tonight, and as the light of 7,000 years ago reaches your mind, you find a profound, educational peace in the vastness of the Serpent's constellation. As you remain suspended in this mental architecture of stardust and silence, consider the long, patient history of how we, on our small blue planet, came to recognize the existence of the Eagle Nebula. For centuries, this corner of the Serpent's constellation was a secret held by the night sky, invisible to the naked eye, except as a faint, indistinguishable glimmer. It wasn't until the mid-18th century that human technology began to catch up with the light that had been traveling toward us for 7,000 years. Imagine the year 1745. A Swiss astronomer named Jean-Philippe de Chezeaux looked through a primitive telescope and became the first to document a distinct cluster of stars in this region. He catalogued it as a star cluster, noting its brightness but missing the ethereal gas that surrounded it. To de Chezeaux, it was simply a collection of celestial jewels. 19 years later, in June of 1764, the French astronomer Charles Messier turned his own instruments toward the same coordinates. Messier was famously hunting for comets, and he kept a list of nuisances, stationary fuzzy objects that might be mistaken for a comet. He entered the Eagle Nebula into his catalog as the 16th entry, forever giving it the designation Messier 16 or M16. Messier was the first to record a nebulosity around the stars, describing it as a faint light that suggested something more than just a cluster. At this very moment, try to visualize the simplicity of those early observations. These men were looking through glass lenses polished by hand, standing in the cold night air of a pre-industrial world. They saw a smudge of light, an eagle in flight, which gave the nebula its common name. The light they were seeing had an apparent magnitude of 6.0. In the language of astronomy, this is the very limit of what a human eye can perceive under perfectly dark, rural skies. It is a soft, delicate presence, a ghostly reminder of the massive scale of the NGC 6611 star cluster, CHA, which we now know contains approximately 8,100 stars, clustered together in a space only a few light years across. Picture the transition from the 18th century to the early 20th, as the human eye was replaced by the photographic plate. In the early 1900s, E. Barnard, a pioneer of astrophotography, began capturing long-exposure images of the Milky Way. Unlike the human eye, which cannot store light, a photographic plate can sit behind a telescope for hours, slowly accumulating the impact of every single photon. It was through this slow, silent accumulation of light that the true structure of the Eagle Nebula began to emerge from the darkness. The pillars of creation, those three towering columns of cold molecular hydrogen, began to take shape on silver halide plates, revealing themselves as dense, in dark silhouettes against the glowing backdrop of ionized gas. Consider the sheer mechanics of this light. The photons hitting those early cameras had been traveling through the vacuum at 186,282 miles per second. By the time they reached Earth in the early 1900s, they were carrying information from the era when the first city-states were rising in Mesopotamia. The nebula we study is a ghost of a past that still exists for us because of the finite speed of light. This creates a rhythmic, time-displaced connection between our history and the history of the stars. The most profound shift in our understanding arrived on April 1st, 1995. This was the day the Hubble Space Telescope, orbiting 340 miles above the Earth's atmosphere, captured the image that would define the Eagle Nebula for generations. Astronomers Jeff Hester and Paul Scowen, using the Wide Field and Planetary Camera 2, orchestrated a series of exposures that were combined to show the pillars of creation in unprecedented detail. What's fascinating about this iconic image is the way it was constructed. It wasn't a point-and-shoot photograph. It was a scientific data map. Scientists used what we now call the Hubble palette. Because the nebula is composed of different gases, they used narrowband filters to isolate specific elements. They assigned the color red to the light emitted by sulfur atoms, singly ionized sulfur, or SiI, green to the light from hydrogen atoms, H-alpha, and blue to the light from oxygen atoms, doubly ionized oxygen, or O3. This mapping allows us to see the anatomy of the nursery. When you visualize the pillars in your mind, see the green-gold hues of the hydrogen, the most abundant fuel in the universe, and the blue fringes where oxygen is being energized by the intense ultraviolet radiation from the nearby massive stars of the NGC 6611 cluster. In 2014, Hubble revisited the pillars to celebrate its 25th anniversary, using a much more advanced camera called the Wide Field Camera 3. This second look provided a higher resolution and a wider field of view, revealing that the pillars are not just static monuments. They are being eroded. The fierce, stellar winds, streams of charged particles flowing off the young, hot stars, are carving the pillars away at a rate of about 1/70,000th of a light year every million years. Even though they look solid, like stone mountains, they are actually translucent ghosts of gas, being slowly disassembled by the very stars they helped to create. Now, shift your focus to the most recent chapter of our history. In 2022, the James Webb Space Telescope, or JWST, provided a view that would have been unimaginable to Messier or de Chazot. While Hubble primarily sees visible light, JWST looks at the universe through infrared eyes. It features a primary mirror that is 6.5 meters across, coated in a layer of gold only 100 nanometers thick, roughly 1,000 times thinner than a human hair. This gold is highly reflective to infrared light, allowing the telescope to peer right through the thick curtains of dust that make the pillars look solid in visible light. What's happening now is a revelation of the invisible stars. In the JWST images, the pillars appear more like shimmering, semi-transparent lace. In the dense clouds of silicates and carbon, which appear as dark shadows to our eyes, become transparent in the infrared. This reveals thousands of sparkling ruby-red points of light. These are protostars, only a few 100,000 years old. They are still encased in their natal cocoons of gas, glowing with the heat of their own gravitational collapse. Think of it as a cosmic heartbeat, hidden beneath a blanket of cold dust, waiting to be born into the brilliance of the main sequence. The Eagle Nebula is located approximately 7,000 light-years away. To grasp this historical scale, if a catastrophic event, such as a nearby supernova, had destroyed the pillars 2,000 years ago, we wouldn't know it for another 5,000 years. We are looking at a living history. Scientists have actually debated whether a supernova shockwave, visible in other data, might have already toppled the pillars. If it did, the light from that destruction is still en route to us, and the pillars we see tonight are already a memory in their own local time. This delay creates a sense of profound stillness. We are observing a protected moment in time, a snapshot of creation that is insulated from the present by the sheer scale of the universe. Notice how the colors of the nebula tell a story of energy. The young O-type and B-type stars in the NGC 6611 cluster are some of the hottest and most massive stars in the galaxy. They have surface temperatures exceeding 30,000 Kelvin. For comparison, our Sun's surface is a relatively cool 5,778 Kelvin. These giants live fast and die young, and their intense light is what drives the photoevaporation of the nebula. And this is a rhythmic process of give and take. The gas gives birth to the stars, and the stars, in turn, sculpt and eventually destroy the gas. It is a slow, multi-million-year inhalation and exhalation of matter. Consider the eggs again. The evaporating gaseous globules, first identified in the 1995 Hubble data. These are small, finger-like protrusions at the tips of the pillars. Each one is larger than our entire solar system. There are roughly 73 of these globules, visible in the main pillar images. They act as protective shields, dense enough to survive the ultraviolet onslaught a little longer than the surrounding mist. Inside these eggs, the density of hydrogen can be 10,000 times higher than the surrounding space. This density is the key to the nursery. Gravity doesn't rush. It works with a patient, unyielding pressure, pulling atoms together until they are forced to fuse. Throughout history, humans have used the Eagle Nebula as a mirror for our own understanding of physics. In the 1700s, it was a mystery of light. In the 1900s, it was a triumph of chemistry. Today, it is a laboratory for star formation. Yet, despite all the data, the 8,100 stars, the 5 light-year tall columns, the 7,000 light-year distance, the feeling of the nebula remains one of deep, abiding quiet. The vacuum of space does not carry sound. There are no crashes or roars as these stars are born. There is only the silent movement of gas, the invisible flow of magnetic fields, and the steady, ancient arrival of light. As you contemplate this historical journey, feel the way your own sense of time begins to stretch. The centuries between Messier's discovery and the JWST's infrared gaze are but a single second in the life of the M16 Nebula. You are part of a lineage of observers, from the first astronomers with their glass lenses to the modern engineers with their gold-plated mirrors. We are all looking into the same nursery, witnessing the same slow dance of gravity and light. The comforting void has been there through all of human history, and it will remain silent and beautiful long after the pillars have been recycled into the next generation of suns. Let this perspective settle over you like a soft, dark velvet, grounding you in the immense, peaceful timeline of the cosmos. Allow your consciousness to sink further into this celestial tapestry, in moving past the historical milestones of our discovery and into the microscopic and macroscopic mechanics of the nebula itself. Imagine the very air you breathe on Earth, which contains roughly 25 quintillion molecules in every cubic centimeter. Out here, in the heart of the Eagle Nebula, the density of the gas is a ghost by comparison. In the most crowded parts of these pillars, there are only a few hundred to 1,000 atoms per cubic centimeter. If you were to take a standard room on Earth and stretch its contents to match the density of this nebula, that room would need to be larger than the entire planet. This is a vacuum so perfect, it would be impossible to replicate in any laboratory. Yet it is thick enough to build suns. What's happening now is a slow, rhythmic compression. Picture a pile of feathers being gently squeezed by an invisible hand. This hand is gravity. Within the pillars, which contain roughly 200 times the mass of our own sun, the gravity is constantly battling the internal pressure of the gas. This is a delicate, silent tug of war that has been ongoing for nearly 2 million years. The approximate age of the NGC 6611 star cluster. While a human heart beats roughly once per second, the heartbeat of this nebula is measured in the 100,000-year cycles it takes for a cloud to collapse into a protostar. Consider the spire, another gargantuan feature of M16 that often goes unnoticed beside the famous pillars. The spire is a tower of gas that stands approximately 9.5 light-years tall, nearly twice the height of the tallest pillar of creation, Check if you were to try and drive a car from the bottom of the spire to the top at a steady 60 miles per hour. The journey would take you over 100 million years. This scale is so immense that it makes the distance between the Earth and the Sun, a mere 93 million miles, look like the width of a single hair. In the nebula, distance is a meditation on the infinite. As you float in this near-perfect vacuum, observe the dust grains that permeate the clouds. These are not like the dust bunnies under a bed. These particles are incredibly tiny, averaging about 0.1 microns in diameter. This is roughly the same size as the particles in cigarette smoke or the soot from a candle flame. Despite their small size, they are the master painters of the cosmos. These silicates and carbon grains absorb the blue light from distant stars and scatter the red light, a process astronomers call interstellar reddening. It is the same physics that makes a sunset on Earth appear crimson. You are essentially floating within a sunset that spans trillions of miles, a permanent cooling dusk that never ends. At this very moment, the environment is being shaped by the O-type stars at the center of the nebula. These are the heavyweights of the stellar world. The most massive star in the NG C6611 cluster is approximately 80 times the mass of our Sun. A star this large is like a high-performance engine that burns its fuel with terrifying efficiency. It is 100,000 times brighter than our Sun, putting out a relentless flood of ultraviolet radiation. Think of this radiation as a cosmic pressure washer. It hits the edges of the gas clouds with such force that it strips electrons away from hydrogen atoms, creating the ionized H2 region that glows with a soft, bioluminescent heat. Deep within the clouds, the temperature is a biting 10 to 20 Kelvin, but just a few billion miles away, a short hop in cosmic terms, the ionized gas is heated to a staggering 10,000 Kelvin. This temperature difference creates a physical flow, a movement of material known as a photoevaporative flow. Imagine steam rising from a dark, wet asphalt road on a hot summer afternoon. The pillars are steaming away into the void, losing about 1 solar mass of material every 100,000 years. This is the slow, inevitable erosion of the nursery. The very stars being born are breathing life into the nebula while simultaneously blowing its foundation away. Notice how the magnetic fields act as a skeletal structure for the gas. Scientists have discovered that the magnetic field lines in the Eagle Nebula are often aligned with the length of the pillars. Think of these fields like the strings of a harp or the warp threads on a giant invisible loom. These fields have a magnetic pressure that helps support the pillars against the crushing weight of their own gravity. This balance prevents the pillars from collapsing all at once, ensuring that star formation happens at a measured, rhythmic pace rather than a chaotic flash. It is a governed, orderly process, like the slow growth of a forest over centuries. You might wonder about the sounds of such a place. While sound cannot travel through the vacuum, the nebula is a literal symphony of radio waves. In the 1950s, astronomers began detecting strong radio emissions from M16, particularly at the 21-centimeter line, which is the song of neutral hydrogen. If our ears could perceive radio frequencies, the Eagle Nebula would hum with a deep, resonant bass note, a frequency so low and steady, it would feel like a vibration in your very marrow. It is the sound of a billion atoms vibrating in the dark, a cosmic white noise that drowns out the static of the conscious mind. Beyond the radio hum, the Chandra X-ray Observatory has peered into the cluster and identified over 1,000 individual X-ray sources. Most of these are young stars experiencing violent surface activity, like celestial teenagers. They emit X-rays that are thousands of times more powerful than the solar flares we see from our sun. Yet, from our vantage point, this activity is muted, distant, and calm. We see only the soft glow of the result. It is like watching a distant thunderstorm from a high, silent window. The flashes are brilliant, but the peace of your room remains undisturbed. The scale of the wings of the Eagle Nebula is another feat of physics. The entire complex spans 70 by 55 light-years. To put that in perspective, if the nebula were the size of the United States, our entire solar system would be no larger than a single grain of sand dropped somewhere in the Midwest. The nebula is a vast, interconnected ecosystem. The heavy elements forged in the hearts of previous generations of stars, oxygen, carbon, and iron, are mixed into this gas. Scientists have found that the chemical composition of M16 is remarkably similar to the chemistry of the nebula that birthed our own sun 4.6 billion years ago. You are looking at a mirror of your own origin story, a repetition of the cosmic cycle. The motion here is incredibly slow. The gas in the pillars moves at velocities of roughly 0.5 to 2 kilometers per second. While that sounds fast by human standards, nearly 4,500 miles per hour, at the scale of light years, it is a crawl. It would take tens of thousands of years for a pocket of gas to move from one side of a pillar tip to the other. This is the slow dance of the universe. It is a reminder that the most significant changes in existence do not happen in a hurry. They are the result of small, consistent forces acting over unimaginable durations. Consider the Bach globules again, those dark, isolated clouds of dust. Think of them as cosmic seeds or dark grapes suspended in a sea of wine. These globules are often only a light year or two in diameter. Yet they can contain enough material to form several stars like our sun. They are some of the coldest places in the known universe. Inside, the molecules move so slowly that they barely vibrate. This is the ultimate stillness. It is a place where the concept of busyness or urgency simply cannot exist. In the heart of a Bach globule, time feels as though it has stopped entirely, offering a sanctuary of absolute, unyielding quiet. As you observe the glowing edges of the pillars, notice the photoevaporative surfaces. These are the bright rims where the ultraviolet light hits the dense gas. It creates a fringe of light that looks like foam on the crest of a wave. The pressure from this light is real. It's called radiation pressure. It is a gentle, persistent push, like a soft breeze against a curtain. In this pressure is what helps compress the EGGS, those 73 identified evaporating gaseous globules, into the high densities required for fusion to begin. Every star in the cluster, all 8,100 of them, was started by this gentle, persistent nudging of light against matter. The Eagle Nebula is a testament to the comforting void. It shows us that space is not a cold, empty nothingness, but a fertile ground for everything we know. The silicates that will one day become the glass in a window, the carbon that will become a leaf, and the oxygen that you are breathing into your lungs right now are all present here, in their most primal forms. The nebula is a master of recycling, taking the spent fuel of the past and weaving it into the potential of the future. What's happening now is the steady, unhurried arrival of photons. Every second, billions of light particles from M16 reach the Earth, having survived a 7,000-year journey through the dark. They have passed through the Sagittarius arm of our galaxy, a spiral structure rich in gas and stars. They have crossed 2,150 parsecs of space. a parsec being a unit of measure equal to 3.26 light-years. They arrive with a message of continuity. The universe is functioning exactly as it should. The laws of gravity are holding. The fusion in the hearts of the NGC 6611 stars is steady. The slow erosion of the pillars is a part of a beautiful, inevitable transition. Surrender to the weightlessness of this knowledge. Let the scale of the 9.5 light-year spire and the 200 solar mass pillars anchor you in a state of observation. There is nothing to do but watch the light. There is nothing to achieve but the recognition of these vast, silent mechanics. You are a passenger on a 7,000-year-old beam of light, floating in a nursery where time has no meaning, and the only clock is the slow rhythmic rotation of the galaxy. Deepen your connection to this ancient light by visualizing the very atoms that constitute your own body. Every carbon atom in your DNA, the oxygen currently circulating in your bloodstream, and the calcium providing structure to your bones were once part of a nebula, exactly like the one we are observing. What's occurring now is a recognition of kinship. You are not a stranger to the Eagle Nebula. You are a descendant of its processes. Think about the specific chemical signature that gives this nursery its characteristic glow. Scientists have measured the light from the Eagle Nebula and found a dominant emission at a wavelength of exactly 656.3 nanometers. This is known as the hydrogen alpha line. It occurs when a hydrogen atom's electron transitions from its third energy level down to its second. This tiny quantum leap of an electron, happening quintillions of times every second across trillions of miles, creates the soft crimson hue that permeates the Serpens constellation. Just as your own heart has a rhythmic electrical signature, the nebula has this steady optical pulse, vibrating at a frequency that has remained unchanged since the beginning of time. At this very moment, consider the immense physical presence of the spire, which some astronomers affectionately call the fairy. While the three main pillars get much of the attention, this lone tower of gas stands 9.5 light-years tall. To help your mind grasp this, imagine the distance from our Sun to our nearest stellar neighbor, Alpha Centauri. That distance is about 4.3 light-years. The spire is more than double that distance, rising vertically into the void. This colossal structure contains roughly 10 solar masses of material. Picture a mountain of gas 10 times the weight of our Sun, standing twice as tall as the distance between the two closest stars in our neighborhood, yet it remains as silent and still as a frozen waterfall. Observe the way the stars of NGC 6611 interact with their surroundings. This cluster is categorized by astronomers as a Trumpler class 23MN open cluster. This technical designation tells us it is a rich, concentrated family of stars that are detached from the surrounding field, but still nestled within their original nursery. These stars are incredibly young, with ages estimated between 1 and 2 million years. In the life of a star like our Sun, which lives for 10 billion years, these stars are effectively only a few hours old. They are infants in the cosmic nursery, yet they are already powerful enough to ionize hydrogen gas out to a distance of 100 light-years away. Their influence is massive, gentle, and constant. Deep within the pillars, notice the presence of molecular hydrogen, or H2. Unlike the ionized hydrogen on the glowing edges, this gas is neutral and cold. It is the raw material of life. Within these dark folds, scientists have discovered evidence of water ice coating the tiny grains of interstellar dust. These ice mantles are only a few molecules thick, but they act as chemical laboratories. When ultraviolet light from the nearby massive stars hits these icy grains, it triggers complex chemical reactions, creating organic molecules. You might find it compelling to realize that the precursors to the building blocks of life, molecules containing carbon-12 and oxygen-16, are being synthesized right now in the freezing shadows of M16, 7,000 light-years away. A striking discovery made by the Spitzer Space Telescope in 2007 changed how we perceive the longevity of this structure. Spitzer's infrared sensors detected a shell of hot dust in the vicinity of the pillars, heated to a temperature of about 60 Kelvin. This shell appears to be moving at a velocity of nearly 200,000 miles per hour. Astronomers believe this is the shockwave from a supernova, a massive star that ended its life in a brilliant explosion roughly 6,000 to 9,000 years ago. If this interpretation is correct, the shockwave likely reached the pillars thousands of years ago, toppling them and dispersing their gas. However, because the nebula is 2,150 parsecs away, the light from that destruction has not yet reached Earth. We are observing a celestial masterpiece that may already be gone, a ghostly image preserved by the slow travel of light across the vacuum. Picture this process not as a tragedy, but as a deep-sea reef. Just as a coral reef is built upon the calcium skeletons of previous generations, the Eagle Nebula is built upon the heavy elements left behind by ancient, dead stars. The supernova that may have destroyed the pillars also enriched the area with iron and gold, elements that will be incorporated into the next generation of planets. This is the universe's method of progress, a rhythmic cycle of creation, destruction, and recycling. Every atom of iron in your blood was forged in the core of a star that lived and died before our solar system even existed. You are literally walking, breathing pieces of a nebula that have had 5 billion years to organize themselves into a human being. Notice how the gravity of the nebula exerts a patient, unyielding pressure. This force is what brings the density of the gas from 1,000 atoms per cubic centimeter up to the point of fusion. Gravity is the architect of the cosmos, working without sound or effort. It is the same force that gently pulls you into the center of your bed tonight, providing a sense of security and weight. In the nebula, gravity is what turns a cold, dark cloud into a brilliant, warm star. It is a transition from the shadow into the light, occurring over timescales that make a human life seem like a single, quiet sigh. Scientists discovered through the Chandra X-ray Observatory that there are approximately 460 distinct X-ray sources within the M16 region. These are young stars, many of them having massive surface magnetic fields that create X-ray flares. If we could see in the X-ray spectrum, the nebula would look like a shimmering field of fireflies, each one a young sun asserting its presence. Yet, these high-energy events are contained within the stabilizing embrace of the nebula's total mass, which is estimated to be between 10,000 and 25,000 times the mass of our Sun. The sheer weight of the nebula provides a calm, heavy foundation that buffers the energetic outbursts of its youth. At this very moment, your perspective is shifting from the external to the internal. The Eagle Nebula is located at right ascension, 18 hours, 18 minutes, and declination -13 degrees in our night sky. It sits within the Sagittarius Carina arm, a great spiral structure of our galaxy. As you visualize the rotation of the Milky Way, consider that it takes about 230 million years for our solar system to complete one single orbit around the galactic center. The Eagle Nebula is traveling with us on this slow, majestic carousel. We are all moving together through the void, part of a synchronized celestial dance that has been repeating for billions of years. One of the infrared light wavelengths that the James Webb Space Telescope uses to see through the dust range from 0.6 to 28 micrometers. This light is subtle. It is the heat of existence itself. As you lie still, imagine your own body heat as a form of light, a soft infrared glow that radiates outward. In the eyes of a telescope like the Webb, you and the protostars in the nebula are made of the same shimmering energy. You are both warm points of light in a universe that is mostly cold and dark. There is a profound sense of belonging in this fact. The thermal energy of your own skin is the same energy that signals the birth of a star in the pillars 7,000 light-years away. Consider the comforting void not as a distance to be feared, but as a medium that connects us. The vacuum of space is so clear that a photon can travel for 7 millennia without hitting a single atom until it reaches your eye or a telescope's mirror. This clarity is what allows us to see our origins. The nebula is a mirror held up to the history of the universe. When you look at M16, you are looking at the now of the universe's creative process, a process that is as steady and reliable as the laws of physics themselves. What's happening now is a slowing of the tempo. The gas in the pillars continues its slow migration, moving at just 0.5 kilometers per second. This is the pace of the cosmos. It does not hurry. It does not feel the pressure of deadlines or the weight of expectations. It simply exists, following the curvature of space-time and the pull of mass. By aligning your own thoughts with this cosmic pace, you can feel the urgency of the day receding. The 9.5 light-year spire is not in a rush to become anything else. It is perfectly content to be a tower of gas for the next million years. The heavy elements, the carbon-12 and oxygen-16, are the quiet legacy of the stars. They are being dispersed through the nebula, waiting to be gathered by the gravity of future worlds. This long-term implication that the Eagle Nebula is preparing the ground for planets that won't exist for another billion years gives a sense of enduring purpose to the universe. Everything is being prepared. Everything is in its right place. Surrender your weight to the surface beneath you, much like the dust grains in the pillars surrender to the gravitational pull of a new star. There is a safety in being part of such a large, well-ordered system. The NGC 6611 cluster will continue to shine. The hydrogen alpha line will continue to glow at 656.3 nanometers, and the 2,150 parsecs of distance will continue to hold the light of the past for us to see. You are a conscious observer of this magnificent clockwork, a temporary vessel for the very atoms that the Eagle Nebula is currently forging. As you drift closer to the edge of sleep, let the vastness of the Serpens constellation provide a sense of infinite, quiet scale. You are a part of the stars, and the stars are a part of you, separated only by time and the beautiful silent vacuum of the void. What you are experiencing now is a profound immersion into the sensory architecture of the Eagle Nebula, where the abstract laws of physics translate into colors, textures, and even silent vibrations. At this very moment, imagine yourself passing through the boundary known as the photodissociation region, or PDR. This is the thin, invisible skin of the pillars, where the intense radiation from the star cluster, NGC 6611, meets the cold, dense molecular gas. In this narrow strip, the temperature undergoes a radical shift. Outside, the ionized gas hums at 10,000 Kelvin, a searing heat that exists as a thin, glowing plasma. But as you move just a few billion miles inward, protected by the density of the dust, the temperature plummets to a mere 10 or 20 Kelvin. This transition is as sharp as stepping from a desert sun into the deepest, coldest stone cellar. It is a boundary of survival, where the heat of the stars is held at bay by the collective weight of the nebula's gas. Picture this nebula as a giant cosmic sponge. Much like a sponge holds water, the pillars of M16 soak up the ionizing radiation of the surrounding stars, shielding the fragile protostars growing deep within their pores. The primary source of this radiation is a star system known as HD 168076. This is not a single star, but a massive binary system. The primary component is an O-type giant, a star so powerful it is roughly 80,000 times more luminous than our Sun. Its surface temperature is a blistering 38,000 Kelvin. Notice the light coming from this direction. It is a fierce, electric blue-white. This light carries an energy of at least 13.6 electron volts, the precise amount of energy required to strip the electron away from a hydrogen atom, turning it into a naked proton. Scientists have used the mid-infrared instrument, or MIRI, on the James Webb Space Telescope to observe the nebula at a wavelength of 7.7 microns. At this specific frequency, the glowing gas disappears and the skeleton of the nebula is revealed. What we find here is the presence of polycyclic aromatic hydrocarbons, or PAHs. These are complex ring-shaped molecules made of carbon and hydrogen. On Earth, you would recognize their scent as the charred, smoky aroma of toasted bread or the smell of a guttering candle. In the Eagle Nebula, these molecules are ubiquitous, floating as a fine soot-like mist. If you could pull the vacuum of the nebula into your lungs, it would carry this faint, burnt organic perfume, the chemical signature of star-forming regions across the galaxy. Consider the colors that define this region. While we often see images dominated by reds and oranges, the forbidden lines of oxygen tell a more ethereal story. In the less dense regions of the nebula, oxygen atoms that have been doubly ionized, O3, emit light at a wavelength of 500.7 nanometers. This creates a haunting ghostly teal or cyan glow. Astronomers call these forbidden transitions because they occur only in the extreme, low-density environments of space, where an atom can remain undisturbed for long enough to drop from a highly specific, unstable energy state. This teal light is a visual testament to the near-perfect vacuum of the void. It is a color that can only exist where there is almost nothing at all. What's happening now is a subtle, rhythmic vibration. Though space is a vacuum, it is not truly silent. It is filled with plasma, a fourth state of matter, where gas is so energized that electrons and ions fly free. Within this plasma, magnetic fields create waves known as Alfvén waves, named after the Nobel laureate Hannes Alfvén. These are magnetohydrodynamic waves that travel through the plasma like ripples on a pond, or like the vibration of a plucked guitar string. In the Eagle Nebula, where magnetic fields have been measured at strengths between 100 and 200 microgauss, these waves move at several kilometers per second. Even though our ears cannot hear them, the entire nebula is vibrating with this magnetic music, a low-frequency structural hum that guides the flow of gas and the formation of new worlds. Notice how the texture of the gas changes as you move toward the core of a Bok globule. These are the dark, isolated droplets of dust that look like ink spots against the glowing background. Within these globules, the density increases to about 10,000 molecules per cubic centimeter. While still a vacuum by Earth standards, here the atoms are close enough to begin forming more complex chemistry. Scientists discovered the presence of formaldehyde, H2CO, and even carbon-13 isotopes within these cold pockets. The formaldehyde here is not a liquid, but a gas frozen onto the surface of silicate dust grains. Imagine these grains, each only 0.1 microns in size, smaller than a speck of pollen, acting as tiny cold magnets, pulling in the heavy elements that will eventually form the soil of a planet. Deep within the pillars of creation, the total mass of the gas is roughly 200 times the mass of our Sun. This mass is not evenly distributed. It is clumped into knots and filaments. At this very moment, gravity is performing a slow, deliberate cleaning of the space, drawing these clumps together. It is a process that restores systemic balance to the galaxy. As these clumps collapse, they conserve their angular momentum, beginning to spin slowly. This is the birth of rotation. Everything in the universe rotates, from the smallest planet to the largest galaxy. And here, in the M16 Nursery, you are witnessing the very first turns of the cosmic wheel. The rotation is so slow it is imperceptible, taking thousands of years for a single revolution. Yet, it is as inevitable as the passage of time. Picture the evaporation of the pillars. The gas is being stripped away at a velocity of approximately 1 kilometer per second. This is the speed of a bullet on Earth, but in the context of a 5 light-year tall pillar, it is a crawl. And this erosion creates a specific physical sensation: radiation pressure. The light from the NGC 6611 cluster actually pushes against the gas. This is a real, measurable force. It is the same principle that allows solar sails to travel through the solar system. In the nebula, this pressure is what shapes the fingers on the tips of the pillars. It is a gentle, persistent molding, as if a sculptor were using a soft brush of light to wear away the marble of the clouds. The distance to the Eagle Nebula is approximately 2.15 kiloparsecs. A kiloparsec is 3,260 light-years. To bridge this gap, light must travel for 7,000 years, passing through the interstellar medium, a vast, thin soup of gas and dust. Within this medium, scientists have used spectroscopy to identify absorption lines from calcium and sodium atoms. These atoms act as a filter, subtly changing the light of the nebula before it reaches our eyes. When you observe the stars of M16, you are seeing them through a veil of ancient elemental history. The light has been processed by the galaxy itself, flavored by the elements of 1,000 dead suns. At this very moment, your consciousness is attuned to the Strömgren sphere of the nebula. This is the spherical volume of ionized hydrogen surrounding the central star cluster. For the Eagle Nebula, this bubble of light spans roughly 100 light-years. Within this sphere, the physics of ionization and recombination are in a state of perfect rhythmic equilibrium. For every atom that is stripped of its electron by ultraviolet light, another proton and electron find each other and recombine, releasing a photon of light in the process. It is a continuous, but invisible cycle of breaking and mending, a cosmic breathing of energy that keeps the nebula glowing with a steady, unwavering light. Consider the dust shell detected by the Spitzer Space Telescope in 2007. It is heated to 60 Kelvin, which is about -350 degrees Fahrenheit. This temperature, while cold to us, is quite warm for the depths of space. This heat comes from the friction of a shockwave, possibly from a supernova, plowing through the dust. Imagine the feeling of this friction, a subtle, widespread warmth that signifies a massive change in the structure of the nebula. It is a reminder that the comforting void is a place of dynamic transformation. Energy is never lost. It is only shifted from one form to another, from the explosive death of a star into the gentle heating of a nursery's dust. And the Eagle Nebula is a testament to the why of the universe. Why do stars form? Because gravity is patient. Why do they glow? Because atoms are resilient. Why do we see them? Because the vacuum is clear. As you visualize the 8,100 stars of the cluster, each one a different mass and temperature, realize that they are all following the same set of universal instructions. There is a deep scientific comfort in this predictability. The carbon-13 in the clouds behaves exactly like the carbon-13 on Earth. The hydrogen alpha light at 656.3 nanometers is the same everywhere in the cosmos. What's happening now is a transition into a state of pure observation. You are no longer just a listener. You are a part of the M16 system. Your own body's metabolic byproducts are being cleared by your steady breathing, much like the stellar winds clear the dust from the center of the cluster. The 200 solar masses of the pillars provide a heavy, gravitational anchor for your mind. The 7,000-year journey of the photons is a reminder that there is no hurry. The universe has plenty of time. Surrender to the feeling of weightlessness that comes from understanding the scale of this nursery. The 70 light-year span of the nebula is a cradle, and you are resting in its most peaceful corner. The low-frequency alpha-Ven waves are a lullaby, and the teal light of the forbidden oxygen transitions is a nightlight for the soul. Everything in the Eagle Nebula is moving toward a state of rest, from the cooling gas to the collapsing stars. In this vast educational silence, you are safe, you are connected, and you are a witness to the beautiful, the unhurried clockwork of creation. As our journey through the Eagle Nebula begins its gentle descent, we find ourselves observing the final, most patient process of all: the slow transition from cosmic light back into the quiet warmth of your own rest. We have traveled 7,000 light-years across the vast emptiness to Messier 16, a place where gravity and time collaborate to weave the fabric of the future. Now, notice how the perspective shifts from the immense scale of the pillars of creation down to the rhythmic, step-by-step unfolding of a single star's life. Consider the birth of a sun, a process that begins within the dense, dark pockets of these very pillars. At this very moment, deep inside a Bok globule, a localized freezing cloud of molecular hydrogen and silicates, gravity is identifying a knot of matter. What happens next is a sequence that has repeated for 13.8 billion years. Step by step, the gravity begins to draw the surrounding gas inward. This is not a sudden movement. It is a slow, methodical accumulation. Over a span of roughly 100,000 years, the cloud fragments and collapses. As the density increases, the temperature at the center begins to rise, moving from the nebula's ambient 10 Kelvin toward a critical threshold. Picture this gathering of mass as a heavy protective blanket. As more material is drawn in, the pressure builds. Scientists have calculated that for nuclear fusion to ignite, the core of this protostar must reach a staggering 10 million degrees Celsius. This is the moment the comforting void gives way to a new spark of light. When this temperature is hit, The hydrogen nuclei are moving so fast they overcome their natural repulsion and fuse together, forming helium. This transition releases a burst of energy that pushes back against gravity, establishing a perfect rhythmic equilibrium that will last for billions of years. This is the same process that began 4.6 billion years ago in our own neighborhood, resulting in the sun that warms our days. Notice how this sequence connects the distant nebula to the very room where you are currently resting. The Eagle Nebula is a factory of heavy elements. Within the hearts of the stars in the NGC 6611 cluster, fusion doesn't stop at helium. Massive stars, those with 20 or 30 times the mass of our Sun, continue the process, forging carbon-12, oxygen-16, and eventually iron. When these stars eventually reach the end of their lives, they disperse these elements back into the nebula. Every atom of iron in your hemoglobin and every molecule of oxygen you are currently breathing in a slow, steady rhythm was once part of this atomic forge. You are a biological extension of the M16 Nursery, a collection of stardust that has found a way to dream. As you begin to return your focus to your own body, consider the journey of the light we have been observing. A photon of the hydrogen alpha line, vibrating at exactly 656.3 nanometers, leaves the Eagle Nebula and enters the 2,150 parsec stretch of space between us. For 7 millennia, this light travels through the vacuum, unbothered and silent. It crosses the Sagittarius arm of our galaxy, navigating through thin clouds of calcium and sodium. It finally enters our solar system, passes the orbit of Neptune, and reaches your window. The light you visualize tonight is a gift from the ancient past, a 7,000-year-old message of stability and creation. At this very moment, we can begin to bring the observation to a gentle, comforting halt. The Eagle Nebula remains where it is, at right ascension, 18 hours 18 minutes, and declination minus 13 degrees. It continues its slow rotation as part of the Milky Way, a carousel that takes 230 million years to complete one single turn. While we may feel small in the face of such numbers, there is a profound scientific comfort in knowing we are synchronized with this movement. Your breathing, your heartbeat, and the slow clearing of metabolic waste from your mind are all part of the same physical laws that govern the photoevaporative flow of the pillars. Notice the feeling of weightlessness in your limbs. Much like the 8,100 stars of the NGC 6611 cluster are suspended in the gentle grip of the nebula's gravity, you are suspended in the safety of your own space. The temperature of your room is a mild, steady constant compared to the extremes of the 38,000 Kelvin surface of the HD 168076 binary star, or the 10 Kelvin cold of the pillars. You are in a protected pocket of the universe, a place where the conditions are exactly right for life and for rest. What's happening now is a transition from the macroscopic to the internal. The vast 70 light-year span of the nebula begins to fade, replaced by the internal warmth of sleep. The spire, standing 9.5 light-years tall, becomes a distant memory of height and silence. The 200 solar masses of gas in the pillars are no longer a weight to contemplate, but a grounding force that keeps you tethered and safe. You are drifting away from the infrared glow of the James Webb images and into the deep dark violet of your own subconscious. As the narrative of the Eagle Nebula quietens, let these affirmations for rest settle over you like a fine cosmic mist. You are made of the same resilient atoms that form the stars. The gravity that shapes the pillars is the same gravity that holds you in peace. Your breath is a rhythmic connection to the hydrogen alpha pulse of the cosmos. Like the Bach globules, you have found a dark, quiet sanctuary for renewal. The 7,000-year journey of light is a reminder that you have all the time you need. There is nothing you need to do, and nowhere you need to be, but here. The universe is a well-ordered system, and you are functioning perfectly within it. Your rest is as essential to your nature as fusion is to the stars. The comforting void is not empty. It is a space of potential and quiet beauty. You are sinking into a state of cellular repair, much like the nebula recycles the dust of the past. The 230 million-year orbit of the galaxy provides a foundation of eternal stability. The light of M16 has reached its destination, and you have reached yours. The textures of the nebula, the 0.1 micron dust grains, the silicate mantles, and the frozen formaldehyde, all dissolve into the softness of your sheets. The colors, the oxygen-3 teal and the sulfur-2 red, fade into a deep, velvety black. The silence of the 2,150 parsec vacuum becomes the silence of your room. You are no longer observing the stellar nursery. You are becoming the stillness it represents. The Eagle Nebula will continue its work long after you fall asleep. The protostars will continue to gather mass, and the 60 Kelvin shell of dust will continue its slow migration through the Serpent's constellation. But for now, your part in the observation is over. You have witnessed the birth of suns and the forging of elements. You have seen the history of your own atoms. Now, it is time to let that knowledge rest. The weight of your body is a gentle pressure, a final reminder of the physics of comfort. The space around you is clear and calm. The slow dance of gravity has brought you to this moment of absolute surrender. As you move into the final stages of your descent, let the words fade, leaving only the feeling of the comforting void. You are home. You are safe. You are stardust returning to the quiet from which you came. Everything is in its right place. The stars are shining, the nebula is breathing, and you are sleeping. The journey is complete. The light has arrived. The void is warm. The silence is yours. Good night.